Hello guys. The live stream on counting figures will be start soon at 7 p.m. So guys, are you ready? Hello everyone. This is Teacher Miu from Think Academy Singapore. Long time no see. Hi everyone. Good night. Good evening. So we are going to have the live stream soon. So please get ready with the material. And today the topic is on counting figures, and we will start at 7. So please get ready with the materials, and we are starting soon. All right, so good evening, everybody. We're starting in 10 seconds, so please get ready. If you do not have your material with you, please get ready with a blank piece of paper. So good evening, everybody. Good evening. So now that it is 7 p.m. now, so let's get started. Today we're talking about the counting figures. Okay, this is a very, very common topics in SASMO and also SMKC for the lower primary students. So let's get started. So first thing first, let's start from one warm-up question. Let's take a look at the first one first. If now Teacher Miu goes to buy some apples, so how many apples are there? So first thing first, this one, it is super easy. We can just count it one by one, right? We can just count it one by one, just like 1, 2, and 3. This is very, very easy. But in a competition, it shall be many of those. So if we have so many apples all at the same time, what should we do? Should we count it one by one? Are there any faster way to do? Yes, you can share your opinion with me in the chat box. So guys, what do you think? If now we have so many apples here, should Teacher Miu count it one by one? Just like I just have like 1 and 2 and 3 and 4 and 5 and 6 like that. Good job, Dia. Yes, we can try a faster way with multiplication. Good job, Dia. So if we are using multiplication, there are 4 groups of 3. So we can say they are 4 times 3. Actually, we have 12 apples here. So for this type of the question, actually, we can use the multiplication with groups to do this question in competition, because multiplication will be easier for us to do the calculation and won't waste our time in competition. So guys, if so, let's try one of the questions from SASMO 2021. This is the question 1 in 2020, so please try this question. It says, how many dots are there in the figure below? So let's try. Now I will just give you 1 minute to try. If you know the answer, please type A, B, C, D, or E in the chat box. I will give you 1 minute. Okay, currently I don't have any of the correct answer. Are you counting it one by one? Shouldn't be, right? We shouldn't count it one by one. There are so many dots here. Well done, dear. I got one correct answer. Excellent. Really? Seriously? Are you counting it one by one? Great. Well done. Actually, 1 minute is enough for you to count it one by one, right? Of course, actually, for this type of question, we can count it one by one. Of course, we can. But are there any faster way to do? I got different opinions. All right. So, okay, time's up. So now let's just try this one. Okay, so for this question, it's very obvious that it's following a pattern. We can see 1 circle with 8 dots, 2 circle with 8 dots, 3 circles with 8 dots, and then 4 and 5 and then 6. So there are 6 circles of 8 dots. So we can just try the multiplication with groups, right? So you can say, 6 groups of 5, 6 groups of 8. So there are 48. Am I correct? Guys, what do you think? Is it 48 the correct answer? Am I right? Not really, right? Not really. What's wrong? Because you look at this part where we are talking about groups of 8. These 2 dots is actually the overlap, which means we have counted twice. That will make us to get to the wrong answers. So how can we make it correct? Now let's try it to consider it not as a group of 8 as a circle, but consider it as a group of 6 to make a letter C. So this is one group of 6, one letter C, right? 2 groups of 6, and then 3 groups of 6, and then 4 groups of 6, 5 groups of 6, and then 6 groups of 6. Now that we have 6 groups of 6, there are 36 dots here. But don't forget, you still have 2 remains. So we will use 36 plus 2 equals to 38 dots. That's why we can come to the answer 38. For counting, actually, it is not a very difficult topic in the competition, but it requires us to count it carefully. Do not count it twice and do not miss anyone. So this is for the first type of the question under the topics of counting. Let's take a look at the second type. Let's take a look at this question. It says, how many triangles are there in the figures below? Now, I will just give you 10 seconds to tell me. Okay, guys, what do you think? How many triangles are there? Please count. All right, dear, how many triangles are there? Time's up. Well done. I got so many correct answers. Excellent, dear. Correct. Okay, so for some of those students who didn't have the our math competition training, that would just tell me that, Teacher Miu, I can find 1, 2, and 3 triangles. But that's not enough, because when we are counting the triangles, we can combine the first one and the second one to get a bigger triangle. And also for the second one and the third one, we can also count it as a bigger triangle. Don't forget, the one and the second one and the third one can also combine as the biggest triangles here. So how can we count them in an order and at the same time won't miss anyone? This time we can use one very single method called enumeration. Let's try it together. So first, okay, I can just label each of the smallest part of triangle as one part of the triangle. Let's take a look. So this one as the one part of the triangle, the second one as the second one, the third one is the third one, right? So if I only consider each part of the triangle as one triangle, let's go. So there would be 1 is the first triangle, right? As you can see, this is the one triangle. And then 2 as the second one, right? And then also we have 3 as the third one. So if we only consider the smallest part of the triangle, now we have 3 of those. But then what can we do? We can just combine 2 triangles, or we say combine 2 smallest part of triangle to make a bigger one. For example, the first one and the second one, can we just combine it as a bigger triangle? Yes, of course. So let's take a look. 1 and 2. This is one bigger triangle that we can just combine to make one. What about for the second one? We can also combine the 2 and 3 as a bigger triangle, right? So this is also what we have. Correct. But can we also combine more triangles to make a bigger one? Of course, okay? Now we can also combine 3 parts of those to make a biggest triangle. So that is 1, 2, and 3 together as the biggest one. So therefore, we have one more biggest one. Altogether, we have 3 smallest one plus 2 slightly bigger one and the 1 biggest one. Altogether, there are 6. Yes, correct. And don't forget, dear, actually, this is what we learned before. It's about counting shapes. We have a secret about this in our long-term course. All right. If you want to learn more, you can just comment in the chat box and let me know about that. All right. So after this part, we can also try one authentic questions in 2020. This is the question 17 in SASMO 2020. It says, how many triangles are there in the figure below? Again, I would recommend you to try the enumeration, this method to try. Now, I will just give you 2 minutes to try by yourself. Let's go. Good to hear, it's too easy. So what's your answer, dear? Not really. It's more than that. Don't forget to do the enumeration. So far, I didn't get any correct answers. Not really. Don't forget. That's too much. That's too much. Not really. See, this is a very tricky question. So let's try again, dear. We can just count it for like one smaller part of the triangle, then combine two smaller part of the triangle to get more. Oh, I got one correct answer already. Good. And then we can just combine three of those and then combine four of those. Do not miss anybody. So far, I only got one correct answer. All right, we still have like 20 seconds. Seems this question is so tricky. You cannot use that secret because it's not under the same pattern. All right, cool. More and more students got the correct answer, so time's up. Again, we can just label every single part of the shapes as a number, just like this is the first one, the second one, the third one, fourth, fifth, and sixth. So for this shape, actually, we have 6 parts of it, right? Let's take one shape first, okay? If we only have one shape, how many different smallest shape is a triangle? Let's take a look. So 1 is the first one, 1. And what about 2? Is 2 a triangle? Let's take a look at part 2. Is this a triangle to you? Not really, right? So do not count it as a triangle. What about 3? Yes, 3 is also a part of the triangle. And what about 4? Yes. What about 5? Also yes. What about 6? Also yes, right? So for only one smaller part to make a triangle, we have 5 now. 1, 2, 3, 4, 5. 5 of those. What about, can we just combine 2 parts to make a bigger triangle? Let's try. Let's just combine 2 parts to make a triangle. But now let's take a look. 1, we can just combine with 4 to make a triangle, right? So 1, 4, that is one triangle. Okay, I won't trace it out for you to see because once I trace it out, it will be so messy. Okay, I will just show you 1, 4 can make a triangle. And can 1 combine with 1 more part to make a bigger triangle? No more, right? Okay, then we go to 2. Can 2 combine any of those to make a triangle? Yes, we can make a 2, 4 as the one triangle, right? 2 and 4 can make a bigger triangle. Can 2 make a bigger triangle with another part? Also can. That is 2 and 5, right? So 2, 5 also can make a bigger triangle. Okay, can 2 make a bigger triangle with the other parts? No more. Then we go to 3. Look at 3. 3 can make a triangle with 5, right? So 3 and 5 can combine to make a bigger triangle. What about another number? No more, right? So then we go to 4. Okay, some students might say, Teacher Miu, 1 and 4 can make a triangle, but dear, 4 and 1, is it the same as 1 and 4? So we counted already. So do not just go back. We should go forward. So it should be 4 and 6 to make a bigger triangle, right? So let's take a look at 4 and 6. This is also a bigger triangle. Can 4 and 5 make a triangle? No way, right? Now let's continue. What about for 5? Then some students also say 5 and 2, 5 and 3. But there we counted already. We have 2, 5 and 3, 5. So we can just only go to 5 and 6. Well done, dear. So we have 5 and 6. Then no more. So for 2 parts to make a bigger triangle, we have 6 of those. All right. What about 3 parts? Let's try 3 parts to make a bigger triangle. What can we make? For example, 1 we can combine with 4 and 6. So 1, 4, 6. That is one bigger triangle, right? 1, 4, 6. Can we make one more? Is it possible to make one more with 1? No more, right? Let's take a look at 2. Can 3 parts of the shapes make a bigger triangle with 2. Only 3 parts. Let's say 2, 4, 5. Is this a triangle to you? No. Let's say 2, 4, 6. Is this a triangle to you? No. And let's say 2, 4, 3. Is it a triangle? 2, 4, 1. Is it a triangle to you? Also no, right? Which means 2 cannot make any triangles with only 2 more parts. Then we go to 3. Can 3 make 1 more? Also can. That is 3, 5, and 6. Any most 3 parts can make a triangle. No more, dear. So we have only 2, where we combining 3 parts to make a triangle. But is it possible that I combine 4 parts to make a triangle? Is it possible? Yes, it is. Who they are? Yes, it is. 2, 4, 5, and 6. So there is 1 more. Altogether, we have 5 plus 6 plus 2 plus 1 equals 14. So altogether, there are 14 triangles. Crazy, right? So for this question, we can use the method called enumeration. So starting from one smallest part, then go slightly bigger by combining 2 parts together, then combining 3 parts together and 4 parts together. Then you might say, Teacher Miu, is it possible to combine 5 parts together? You can try by yourself to find out. All right. So after that, let's come to the one more one. It's about counting 3D shapes. For counting 3D shape, this is also a very common topic in the competition, no matter it's about SASMO or SMKC. So let's take a look at these cubes, guys. How many cubes are there? Let's count. I will just give you 30 seconds for this question. Guys, what do you think? How many cubes are there in the figure below? You just count. All right, I got some correct answers, some crazy answers, some. All right, sorry. We still have like 3 seconds. All right, I got different opinions. Okay, so guys, how can we count the cubes? Are you counting it one by one? No way. Because some of the cubes we cannot see, so we cannot count it one by one. Okay, so today, Teacher Miu will tell you about a very funny method. It is called the boardman method. How can we do the boardman method? So first thing first, you can see each of the column as a building. Right? So it's just like the buildings on the street. Oh, so many buildings here. We have so many buildings here. And now we are going to count how many levels are there of each of the buildings. If so, where should we start from? Shall Teacher Miu start from the tallest building? No, there are some of the cubes I cannot see, right? I cannot see, which means we cannot start from the tallest one because the tallest one is covered by some of the cubes that I do not know. So we should start from the shortest one. So for the shortest one cube here, how many cubes are there for the shortest one? There is only 1, right? Now that we know there is only 1 here, can Teacher Miu just label the 1 here, the face? Then I say, oh, this is also 1, this is also 1, this is also 1, this is also 1, this is also 1. So for this place, I already got 6 already. No, cannot. Just like this cube, you can see 2 faces of it. So if you label 1 on this face, you label 1 on this face, you count it again. So that doesn't make sense. Which means you cannot label it on the face, but it only has 1 top. That means you can label it on the top, right? So let's go. Let's just label it on the top, just like just like the boatman sitting on the building on the top and give you a 1. So this is the building with only 1 block. And the boatman again here. So again 1 and again 1. Any other buildings with only 1 cube? No. Then we go slightly taller to the next building that is with 2 cubes. So let's take a look at the boatman sit on the 2 cubes. So we label a 2 on the top. And then what next? We shall go to the buildings with 3 cubes, right? So this is 3 and this is 3. So all together, we have 1 plus 1 plus 1, 3 ones, plus 2, 1, 2, and then 2 threes, plus 3 plus 3. Altogether, it shall be 11. So this is what we call the Boltzmann method. We count by column, right? We count by columns. This is very easy. But what about this one? For this one, shall teacher Miu also count it by column? Use the Boltzmann method? Okay, so if so, now teacher Miu will just try to let you see, all right? So for this one, we just go 1, 1, 1, 1, 1. And then we got 2, 2, 2, and 3. So altogether, I have 1 plus 1 plus 1 plus 1 plus 1. So many ones to plus, and then plus 2 plus 2 plus 2 plus 3. Yeah, so long. I just do not want to do like this. Any other faster way that we can do in the competition? Apart from taking a look at the cubes in columns, we can also take a look at the cube as the each layers. We can just see that as the layers that it would be easier to do. Yes, of course, we can use multiplication. But now teacher Miu will teach you another way called the lazy method. We can just count it in layers. Let's take a look at the top layers. For the top layers, how many cubes you can see? There is one lazy cube at the top layers, right? There is only one here. But what about for the second layer? Can teacher Miu say, I can see 1, 2, 3. So there are 3 cubes for the second layer. Can I say so? No, why not? Because actually, there is one very heartbreaking one. Okay, let me just take it out for you to see. Look at this one. The 3 ones we can see, they are so lazy that nothing is on it. But for the missing one that we cannot see, actually, he's working so hard. He was working so hard to carry the one on his top. Right, so for this layer, you can consider it with the working cube at the lazy cube. What does it mean? For the lazy cube, is actually the cubes we can see here. 1, 2, 3. 3 very lazy ones. They do not need to do anything. So we have 3 lazy cubes. And also there is 1 cube that we cannot see as he was working so hard to support the one on his top. Just like this one. Right? This is the one we do not see because he was supporting the one on the top. So for this layer, we have 3 plus 1 equals 4. Then you might ask, teacher Miu, how do I know how many cubes are working? Guys, they are working to support the upper layer. So how many cubes are there on the upper layer? Then you need how many more cubes to work? That's how we can get it. All right. And then what about for the next layer? Then how many cubes for the last layer? That must be the lazy cube that we can see. We have 1, 2, 3, 4, 5. 5 lazy cube that we can see. And also the working cube, who we cannot see but supporting the upper layer. Those should be 4. Altogether, there shall be 9 cubes for the third layer. So let's check whether is it. I will just take it out for you to see. Hey, see, there are 5 lazy cubes without anything on the top, and also 4 of those supporting the upper layers. So altogether, now it is much more easy now. We have 1 on the top, 4 at the second layer, and then 9 at the bottom layer. They are altogether 14 cubes. So this is actually one way we call it lazy method. We count by layers. So when you are doing the competition, you can just choose the way that you're familiar with and the way you like. Some of you might like the Boltzmann method. Try to do it columns by columns. Some of you might like the lazy method. Do it layers by layers. Either way works. All right. So let's try. Let's take a look at the SASMO questions in 2016. Counting cubes. It says, the diagram shows some cubes of same size at the corner of the room. How many cubes are there all together? All right, so now it's your turn. I will just give you like 1 minute to try. I will give you some tips on this. You can either try the boatman method or the lazy method. Let's go. Well done. I got some correct answers already. Well done. Oh. Wow. Seems that this question is very easy for guys, right? That's good. Oh, I got different opinions. All right then. Okay, time's up, dear. So for teacher meal, actually I like boatman method. Okay, you can just choose the way you like. Okay, for boatman method, let's try the boatman method first. Starting from the short teeth building, label the number on top. So we have 1, 1, 1, 1. We have 4 ones. So 4 groups of 1, that gives you 4. Right? And then for the 2, we have 2, 2, 2, 2. Again, 4 groups of 2. That we have 8. Then for the 3, we have 3 and 3. They are 2 groups of 3. So they are 6. Altogether, 4 plus 8 plus 6 equals to 18. So that's why we can get to the answer C. This is one way to do with the boatman method. Also, dear, you can try with the lazy method. So let me just try the lazy method here. Okay, for the lazy method, let's start from the top first. Let's take a look at the top. For the top layer, how many lazy cube you can see? You can see there are 2 lazy cube because you can see nothing is on your top. You're not carrying anything. So there are 2 lazy cube. And how many working cubes are there? Actually, because it is on the top, so there are nothing. Okay, there is 0 working cubes. So for the top layer, we have 2 plus 0 equals to 0, right? What about for the second layer? We say for the middle layer, that how many lazy cubes are there? That means you can see his boat head, he's not carrying anything. So there are 1, 2, 3, and 4. We have 4 lazy cubes here. What about for the working cube? They are working so hard to carry the layers on the top. So there must be 2 of them working for the middle layer. So for the middle layer, there should be 2, 4 plus 2 equals 6 cubes, right? What about for the bottom layer? Let's take a look at the bottom layer. How many lazy cubes are there? You can see there is 1, 2, and 3, and 4. 4 of those are not working, so lazy. What about the working cubes? The working cubes are working because they need to support the upper layer. So that's why we will have 6 working below. So altogether, they shall be 4 plus 6 equals 10 cubes at the bottom layer. Altogether, 2 from the top, 6 at the middle, and 10 at the bottom, they shall be 18. We can get to the same answer. That's how we can do the counting cubes. So let's go to the summary for today. Today, we talk about counting figures. We can count the 2D figures, we can count the shapes, we can also count the cubes. For counting 2D figures, you can use the multiplication with groups to make it easier and faster. And for the shapes, especially for the triangles, rectangles, and squares, you can use enumeration to find out the correct one. And for counting cubes, we have 2 methods to go. One is called the boatman method. We can just count by columns. And also the other thing is on the lazy method. We can count by layers. All right. So these are the summaries for today. I hope you enjoyed tonight. And this is Teacher Miu from Think Academy. Please do the practice in the group. And see you guys next week. Bye-bye.